Okay, so yesterday we talked about relations, which again, relations are just a group of coordinates. And then we talked specifically about functions. What makes something a function again?
There's no repeating numbers.
There are no repeating numbers for x, exactly. What we're going to talk about today is how you can write the equation of a special kind of function called a linear function. Now, when you look at the word linear, does anybody see another word within that word? Line. Right? So when we're talking about something that's linear, we're talking about something that when you draw it is a straight line. Okay. And there's one popular equation we use quite a bit in this class to represent the equation of a line, and it's called y equals mx plus b. And I'll draw a picture of something in y equals mx plus b in a minute. Y equals mx plus b has 4 letters in it. When we write a final answer to a problem, this letter turns into a number, and so does that letter. Does anybody know what the m stands for in this equation? No, not minute. It doesn't begin with an M actually, what it stands for. Neither letter here is what it stands for. Well, how do you describe how the steepness of a line is changing? What is that called? The slope. Yep. So the steepness of a line is the slope, and B is something else. Anybody know what the B is? Yeah?
The Y.
The Y what?
Try to solve for y.
Intercept. What does that mean? Can somebody give me like a simpler word? What does y-intercept mean? Yeah.
Where the line meets the Y, or no, the X. Yeah, the Y line.
So so the y-intercept is where this does what?
It meets another line.
Meets something else. Anybody know your
Y-axis?
Yeah, the y-axis.
Yeah.
So the y-intercept is where your line meets the y-axis. Okay, let me show you guys an example. I'll let you pick a number. Let's pick a number for m. Somebody give me a, how much? It's too steep. Well, let's pick a pretty small number. 6. So y equals 6x. And now pick a y-intercept. 4? Okay, so y equals 6x plus 4. If I hit graph, let's take a look at what we have. So the y-intercept was a 4. If you count up 1, 2, 3, 4, that's exactly where it crosses the y-axis. It crosses at 4. Kind of put a dot to show you. And the 6, when we put that in, 6x, that controlled how steep the line was. What do you think would happen if I put in something like 3x plus 4? Where is it going to cross the y-axis now? Still going to cross at 4, but what do you think the 3 is going to do?
It's going to be much steeper.
You think a smaller number is going to make it steeper?
No.
Less steep. Yeah, it's going to make it less steep. So it still is going to cross at the same spot, but now it's not quite as steep as the other one. It's a little bit more. Yeah, it's more tilted. Like in the smaller we make that number, the more tilted it becomes, and eventually we could even make it horizontal. Okay, but that plus 4 is always going to control where it crosses the y-axis.
If you do negative times.
So if we do like a negative, let's just get rid of some of these so we don't have so many. If you put in a negative, let's do negative x plus 4. They're both going to cross at 4.
It's gonna mirror. Instead of one way, it goes the other way.
Yeah, so which one of these do you think was the negative, the red or the black? The one that's going down to the right, the red one.
So it's basically mirrored.
Yeah. Okay, so the red one has a negative slope, which causes the line to go down to the right. The black one has a positive slope, so it goes up to the right. Okay, but anything that's in that form, y equals a number with x plus a number at the end, is always going to be a straight line. That's a straight line. It's not the only way to write an equation of a straight line, but it's the one that we use quite a bit. Okay, so the next thing on your guided notes you have right below the double dashes where you filled in the graph is a straight line. You have another bullet, and you want to fill in a linear function. Okay, what is a linear function? Okay, it's a function whose graph is anything except a vertical line. Yeah.
Do you have a pencil?
A pencil? Yes. So a linear function is a function whose graph is a non-vertical line. Now, why can't it be vertical? What test did we learn yesterday?
Vertical lines.
Right, we learned the vertical line test. So if a line that's vertical hits a graph more than once, what do we know? It's not a function. So the only type of line that you can draw that is not a function is a vertical. If you draw one like this, that's a function. That's a function. That's a function. That's a function. This one, not a function. But all of these lines right here are functions. The only one that's not is if you draw it vertical. Any question on that? Now, what if I do something like this? Just draw it like that. Is that a function? What do you think?
Yes.
Yes.
Yeah. Because if I take a vertical line and I drag it through, it never hits more than once. Okay, no matter where I put it. It only hits exactly one time. Now, so we know it's a function. Is it a linear function?
No.
No. Why not? What shape does it have to be linear?
Straight line.
Has to be a straight line. That's curved. So it's a function, but it's not linear. It has to be straight to be linear. How about if I did something like this? Let's put this one here. First of all, what do you think? Is that a function? Yeah, because no matter where I put my vertical line, it only hits one time. Is it a linear function? Yeah, so that one's a function, and it's a linear function because it's a straight line. How about this one? Is it a function? No, it's not a function because it fails the vertical line test. Okay. Is it linear? Well, no, it's not linear either because it's not a straight line. All right, so that's two different questions, asking whether or not something is linear versus whether it's a function. Okay. Function just has to pass the vertical line test. Linear means it has to be straight. Okay. So right below where you wrote a linear function, we have the double dash again. You can put has a constant rate of change. What that means is a constant slope. Let's draw this line like this. If you stand here and someone else is standing here, how would the steepness compare from where you're standing to where your friend is standing? Okay?
The elevation is lower where I'm standing versus where my friend is.
Okay, just like the steepness, like pretend you're both standing on that hill.
It doesn't change.
Yeah, the steepness is exactly the same, whether you stand here, here, if you stand here, or you stand here. It's going to be exactly the same steepness in all those spots. Yeah.
That doesn't matter.
Yeah. Is there any question why the steepness is the same there? That's called a constant slope. Now, let's say you had something like this. If you stand here, and your friend stands here, is that the same steepness? No, you're standing on a spot that's flat. Looks like your friend is standing on a spot that's going uphill. You could have someone else standing on a spot right there that's going downhill. That's not a constant slope. The slope changes, the steepness changes, depending on where you are. Okay? We're not going to look at ones where the steepness is going to change like that. We're going to look at ones that when you draw it, no matter where you are, it's exactly the same steepness all the time. All right, so that's what that means, constant slope. Okay, so a nonlinear function, so all you have to do is write in the words nonlinear function, does not have a constant slope. So what does that mean? Anything that curves doesn't have a constant slope. Anything like that. Like that. None of those graphs have constant slopes. They all change depending on where you're standing. Some are more uphill, some are more downhill, some are perfectly flat. So any question on why none of these are linear functions? Now let's just ask if they're functions. Okay, that's a little more general. Is this one a function?
No.
No. How about the one on the right that has that wave shape?
No.
No, that fails the vertical line test. How about this one? Is this a function? Yeah, it's a function, but it's not a linear function. Okay. All right, so what I'm going to do is I'm going to put up a few graphs, and I'm going to give you guys a few minutes to try and tell me whether the following graphs represent linear or non-linear functions.
Yep,
you have to draw the pictures. You don't have them. Okay, so start with those two. And then you'll answer the question, does the graph represent a linear or a non-linear function? Let's look at the first one. A. Is that a linear function or non-linear function?
No.
Yeah, that's a non-linear function. Okay, so two questions for you. Why is it non-linear? Yeah? It curves. That's why it's non-linear. Why is it a function? Yeah?
Because the points don't go on top of each other and it passes the VLS.
VLT, yeah. Passes the vertical line test. So that's why it's a function. Yep, exactly. Right, let's look at B. Is that a linear or non-linear function? Yeah, that's a linear function. Is it linear because it passes the vertical line test?
No.
No, that's not why it's linear. It's linear because the slope never changes. Okay? It's a function because it passes the vertical line test. Any questions on that one? Right, let's try C and D. So here's two more graphs. And I want you to tell me if these are linear or non-linear functions. Okay, so same directions. All right, so let's take a look at C and D. Eli, what'd you get for C? Can you be more specific? It asked us to do a little bit more than that. It's a linear function. So it's really asking us for two things. Is it straight? And does it pass the vertical line test? So that's a linear function. Perfect. And what about D? What'd you get for that one, Brady?
I say non-linear
That's part of it.
function.
Function, right. It's a non-linear function. Okay, so let me ask those two things again. Why is this one non-linear? It's not a straight line. You might say, well, yeah, but each part of it is straight. Yeah, but there's two different slopes. If you were standing here, you'd feel like you're going to fall downhill. And if your friend was over there, they would feel like they're going uphill. It's not the same slope everywhere. So that is non-linear. And what makes it a function?
They never touch the vertical line test.
Right, it passes the vertical line test. Okay. Any question on the difference between answering linear versus non-linear functions? Okay. So what I want to do now is take a look at how can we identify if something is linear or non-linear from a table. Okay. We've identified if something is a function or not a function from a table by looking for repeats in the x values. Now I'm going to show you how to look at a table and tell if it's linear or not, because you might not always have a picture to go off of. Okay, so let's make a table. This part, we're just going to do this together, and then I'll let you know when we're going to write something down. Okay, but I just wanted to do this part with you guys. All right, so let's make a table and see if we notice any patterns. What I'm going to do is I'm going to label some points on this line. I'm just going to write them down and see what happens. Let's start with this point. What's the coordinate? Make it a little bigger so you can see it. What's the coordinate of this point down here? -3. -3. Yep. So it's -3. -3. All right. How about the coordinate of that point? I think -2, -2 would be right there. -2, -1. Yep. So that's that one. Can someone else tell me what's the coordinate of that point? Yep.
1 over 1. And -2.
-1.
-1 and -2. No. -2. No.
1 and -1.
So -1,
Yeah.
up 1. And that gives you what? What does that give you? -1, comma?
It would be -1 over 1.
Comma 1. Because you're going to write a coordinate.
Okay.
So -1, 1. How about this? What's the coordinate of that one?
Zero,
0, 3. And Lily, what about the last one?
That one would be +1, 5.
Yeah, +1, comma 5. Right. So what I want to do is I want to look for a pattern and just see if we notice anything. How do you get from -3 to -2?
Add 1.
Add 1. Okay. How do you get from -2 to -1?
Add 1.
Add 1, and then here? Add 1. Okay, it's always adding 1. Okay, that's one thing we're going to look for. Okay, if the x's go up by 1 each time, let's see what happens to the y's. This is the important part. How do you get from -3 to -1? You add 2. Now, as long as the x's are going up by 1s, the y's have to have the same pattern each time. So the pattern here was add 2. Do you add 2 to get to here? Yes. Do you add 2 to get to here? Okay, and you add 2 to get to here. Then that is linear. The key is you have to add the same number each time in order for it to be linear. If this one, let's say this was like a 7, then I would say, okay, this is a +2, +2, +2. Oh, that's not a +2, that's a +4. That would no longer be linear. Okay, so the key is you add the same number each time. That makes it linear. So let's write that down. So when I say consistently, I mean the same. Consistent means the same thing. So it says it is a linear function if as x goes up by adding the same number. So in our case we did +1, +1, +1. I think it's usually going to be a +1. So as x goes up by adding the same number, y also changes by adding, could also be subtracting, but it has to be the same number every single time. So in our case, it was a +2. +2, +2, +2, +2. If it was a -2, -2, -2, that'd be okay too. But y has to change consistently by adding or subtracting. If your y values do like a +2 and then a +3 and then a +1, that's not consistent. It has to be constant. It has to be the same. If y doesn't change at a constant rate, if it's not plus the same number every time, then what you would have is something that's non-linear. Okay, non-linear. That means it would probably have some kind of curve to it, or it could be a V shape, but it's not a straight line. Okay, so I don't think you didn't have the double dash right below that dot. If you want to add it in right next to example 2, you have a little space. You could just put if y doesn't change consistently, or if that doesn't make sense, you could write if y doesn't add or subtract the same number, then you have something that's non-linear. Okay, so what we'll do now is we'll take a look at some tables, and we're just going to figure out if they are linear or non-linear. They're all going to be functions. Okay, there's no question about that. They're all going to have no repeats in the x's. So they're all functions, but I want to know if they are linear functions. Okay, so here's our first table. Remember, the check is, are you adding or subtracting the same number each time? Let's check the x's. How do you get from 3 to 6? Add how much? 3. And then how do you get from 6 to 9? Add 3. And 9 to 12. Okay, is that all you need to check and now you know it's linear? No, what do you have to check? Yeah, you got to check the y. So the x's have to go up the same amount, and the y's have to go up or down the same amount. Okay, how do you get from 36 to 30? -6. So now that has to be the pattern every time. If it's not -6, then we have to write nonlinear. How do you get from 30 to 24? Yep, from 24 to 18? Okay, so it was the same thing each time. In this case, subtraction. So because it was the same, is this linear or a nonlinear function?
Oh, linear.
What is it?
Linear.
Yep, this is linear. So all of these numbers have to be the same, and all of those numbers have to be the same. These numbers don't have to be the same as each other. They don't have to be +3s in the top and all +3s in the bottom. It's just the top have to be all the same, and then the bottom can be a different number, but all the same. All right, let's try B. Okay, let's check the x's first, and then we'll check the y's. How do you get from 1 to 3? Add 2. And 3 to 5?
2.
Add 2. And 5 to 7? Add 2. Okay, so that's good. All the x's are adding the same number each time. Now, let's try this. How do you get from 2 to 9? You add 7. How do you get from 9 to 20?
No.
Yo, I love
You add 11. So we can stop. What do we already know? It's what?
It's a nonlinear.
This is a non-linear function because you did not add the same value in the y's. Okay, so non-linear function. Okay. Any question why it's non-linear? Okay. Why is it a function though? Right, there's no repeats in the x's. I told you there'd be no repeats in all these problems. 1, 3, 5, 7, 3, 6, 9, 12. No repeats in the x's, so they are functions, but they're not straight lines. All right, so why don't you guys try C and D. And remember, you're just writing down whether it's a linear or a non-linear function. Right, and we'll check in with you guys as you do those. Okay. What are you doing in the x's each time for C?
Adding 1.
Okay, you're adding 1. And that looks like it's the same pattern each time. How about in the y's?
You're adding 2.
Yeah, adding 2, 2, 2. So what do we think? Is that a linear function or a non-linear function?
linear.
Yep, that's linear because you added the same number each time. So linear because you add the same number each time. Function because there are no repeats in the x. Okay, so I'm really trying to explain that difference between something being a linear versus nonlinear and a function versus not a function. It's really two separate things. Okay, let's look at this one. Are there any repeats in the x?
No.
No, so it's definitely a function. Now the next step is to determine if it's linear. Okay, what do you do each time to get from one x to the next?
Add 1.
Okay, we're adding 1. How do you get from 16 to 8? And remember, you're just thinking adding and subtracting.
-8.
Yeah, minus 8.
And then you do -4, so then you just dump it in this.
Yeah, and that's a -4. So that is what kind of function?
Linear.
That's nonlinear. Yep. Okay, so nonlinear function. Okay, so any question on figuring out if something is a linear or a nonlinear function by looking at a picture or looking at a table? Okay, so the last thing is going to be looking at a formula. The only kind of formula that is linear is if it looks like that, or it can be made to look like that. For example, does that fit this pattern, the one I just wrote right there?
Yes.
Yes, it does. How about this one?
Yes.
Yeah. I just made m negative 3 and I made b negative 4. How about this one?
Yes.
Does it fit the pattern the way it's written? No.
We could make it.
Could we fix it so it does look like that?
Yes.
Yeah, what could we do on both sides?
+2.
We could plus 2 on both sides. And now, it looks exactly like it. How about this one? Does that one look exactly like the pattern?
No way to fix it.
No, but how could we fix it so it does? Divide everything by 2, 2, and 2. And we get y equals 2x plus 5. These are all examples of linear functions because they look like this. So it either has to look like that or it can be rearranged to look like that. Right? If it's anything other than stuff that looks like this, it is not a linear function. So I'm going to show you some things that are not linear functions and things that are. Okay. Let's say you had something with a square root in it. Okay. I'm just going to fix that. Let's say you had something like y equals the square root of x. Well, let me just show you what that looks like. So this is the square root of x function. What do you think? Linear or nonlinear?
No.
Nonlinear. It has a curve to it. Okay, so anytime you see something that has a square root in it, that's no good. It's nonlinear. If you have a variable in the bottom of a fraction, okay, let me type that one in. 2 divided by x. What do you think of that? Linear or nonlinear?
No.
Definitely nonlinear. It's not a line at all. So if you put a variable in the bottom of a fraction, that's not going to work. Yeah, making a list of things that don't work. That's what I'm doing. If you have a variable up in an exponent, like y equals 4 to the power of x. Okay, let me graph that one. Yeah, it's a lot. It's every day. I don't know. Yeah, put a bigger sign on the door. So y equals 4 to the power of x. What do you think? Does that look like linear or nonlinear? Definitely nonlinear. It's another one that curves. Okay, so variables under a square root symbol, variables in the bottom of a fraction, variables in an exponent. Right? Let's try a variable with an exponent that's not a 1. So I'm going to put in a variable with an exponent that's not a 1. Let's do a 2. Let's try x squared plus 3. We actually looked at one like this in the notes today. Remember the one that looked like a U shape we did? Kind of like that one? Is that linear or nonlinear? Definitely nonlinear. So any of these situations are not, I forgot the word linear. I don't think I printed that on the notes either. So you know what? Just put it all on the blanks. Just squeeze in. These types of equations are not linear functions. They might be functions, right? If we look at this one, does that pass the vertical line test?
Yeah.
Oh yeah. Yeah, if you draw a vertical line, it only hits it once. So it's a function, but it's not linear. Okay, so those are the things you want to look for when you're looking for something that's non-linear. These are the kind of things you want to look for when you're looking for something that is linear. Everything that has a box around it. Notice there's no square roots. There's no exponents. I don't have like an x squared or something like that. I don't have variables in the bottom of fractions. I don't have any of those things I said you couldn't do. Right? Those are all linear. Okay, so now what we'll do is we'll try I'm going to give you some examples, and we're just going to write down whether they're linear or nonlinear. So which of the following equations represent linear functions? I'm going to skip this one. We'll come back to that one. I'm just going to go down. So I'm going to start with E. Remember, you want it to look like this. The way E is written, does it look exactly like y equals mx plus b? No. Could we do something and then it would?
Yes.
Yeah, what could we do with the 6? Distributive property. What do you get if we do the distributive property?
6x minus 6.
Now, does it look like a linear pattern?
Mm-hmm.
Yep, it is. So which of the following functions are linear? I'm going to just circle the ones that are linear. E is definitely linear. Okay. How about B? Y equals the square root of x. No, we said square roots. Can't have a square root. It's not going to be linear. How about F? No, that's non-linear. You can't have something with a power of 2 or 3 or 4. You can't have any number in that exponent that's higher than a 1. Okay, so that is definitely non-linear. How about C? Linear or non-linear? No, you're not allowed to have variables in the exponent. That's one of the things we talked about. That is non-linear. How about G?
Linear.
That's linear, right? What number is in front of x even though it's not written?
1.
1. That's exactly y equals mx plus b. Okay, so that one's perfect. All right. How about D? Y equals 2 divided by x.
No.
Yes.
It is linear?
Yeah, we just have to fix it a little bit.
No, it's not.
Why
The
not?
variables at the bottom of the fraction.
So we have a 2 divided by x. You're not allowed to have a variable in the bottom of a fraction. All right. So that one is non-linear. Any of these things make it non-linear. All right, so nope. Okay, H. Another way you could kind of think of H, you could also think of it, this is the same thing.
Yeah, that one.
Yeah, that's linear. What does it look like is missing there from having it look exactly like this? Looks like the M is missing? The thing that's in front of the X?
The plus and bit.
The B is missing. Well, since the B isn't there, it's really like you're just adding what?
1.
Not 1, because if you put a plus 1, that would change the problem.
Oh, 0.
It's like a plus 0. There's nothing there. That's linear. That's fine. That is y equals mx plus b. So if you don't see a number here, that's fine. Just pretend like it's plus 0. And if you see the x in the top, or you see it right next to it in front, it's exactly the same thing. Whether you put it there, or you put it in the top. That doesn't make a difference. Okay, so the things you want to be careful, square roots, variables in the bottom, variables as exponents, and numbers bigger than a 1. That's an exponent.
Are we going to go back to A?
Yeah, I was thinking about A a little bit, how I wanted to handle that. Okay. Does A look like y equals mx plus b?
No.
Not at all. It doesn't even have an x in the problem. So technically, that is not a linear function. It's called a constant function. I'm not going to really talk more about that right now. but it is not y equals mx plus b. Okay, so any questions on identifying linear versus nonlinear? Okay, so hopefully you guys feel pretty good about doing that. We'll do a little bit more in this section tomorrow. Okay, so homework for tonight is 3.2 part 1. Tomorrow is going to be 3.2 part 2. And if you want to do the review guide, that will be the extra credit on the test. And I'll be after school on Wednesday this week.